Okay, so now let's talk about how do we compute the partial derivatives for a sphere, because remember, we need these quantities. We need dp du and dp dv for a sphere. So how does the position change, basically the tangent vectors, how does the position change on the sphere as we go along the u and v vectors? Now remember, we can draw our sphere like that, x, y, z, a point P. Theta is the angle we make with the y-axis, and phi is the angle we make with the x-axis. Now we know that if this distance is r, we know that x is equal to r sin theta cos phi, and y is equal to r cos theta, and z is equal to r sin theta sin phi. Okay? So from here we have learned how to compute theta and phi in our last texture mapping. Right? We can simply find, we can say that theta is equal to tangent minus 1, cosinus minus 1, cosinus minus 1 y divided by r, okay, and phi is equal to tangent minus 1 z divided by x. Now theta and phi are not enough for us. We need to go to uv because we are accessing the texture using the uv coordinates. So what we must do is, from here we must find u and v. Let's be consistent with ourselves. So how did we compute u in texture mapping? Minus phi plus pi divided by 2 pi. Okay. So in our case, as u is increased, we go along this direction. Note the minus here. And v is equal to theta over pi. Okay. Now from this formulation, you can rewrite the x, y, z as follows. Okay, we can write x is equal to r sin theta. Okay, so this was v. So what is theta? Theta is v times pi. V pi cos phi. So what is phi? Phi is equal to, how can we compute phi from here? It is pi, okay, minus u 2 pi. So multiply this and switch sides. Okay. So similarly, we can write y as r cos theta. Okay. Cos, what is theta? V pi. And z is r sin v pi, and sin phi. What was phi? Phi was this pi minus u 2 pi.